Today, we are doing electricity. Why is it appearing back in my screen? Hang on. Okay, we are doing electricity, but we are continuing on last week's chapter. Okay, so last week, if you recall, what we did was we actually introduced the chapter on electricity using the. Did we do Kahoot last week? I think we did a bit, right? There's one small Kahoot, right? I think where you all get to know, learn. They show you what are the symbols in a electric circuit, and then whether if you close this circuit, you open this circuit, the light bulb can light up or doesn't light up, all those things, correct or not? Okay, so last week, if you recall, what we did was the introduction to circuits, meaning they introduced to you symbols, they introduced to you the meaning of open circuit and closed circuit. Okay, so for today, if you look at the screen, right, you see this. You're going to learn about series and parallel circuits. There's a little bit about energy conservation, electrical energy conservation at the end. Okay, but I'm more interested in this part, series and parallel circuits. Okay, this one you can use a bit of your common sense and your like daily experiences to answer this question. Of course, you need to phrase it properly, but otherwise, like this thing is like very content based. You read, you remember, you can answer already. Okay, but this is the part for today that I will focus a little bit more because it involves like new, I would say new lah, I don't want to say difficult, new science concepts. Actually, it's not difficult, I will try my best, okay, to make it as easy for you all to understand as possible. Okay, so if at any point of time, right, you are lost, right, when I'm doing the series and parallel circuit teaching, you let me know. Okay, you raise your hand, or you like, if I'm engrossed on my screen, I cannot see your hand raised, then you just verbally tell me that, sure, okay, can you repeat and stuff like that. Okay, this one very important. You must understand. So don't be shy. Don't think like I paiseh later my friends see me raise hand. No need. All that no need. Okay, it's for your own learning So just say repeat. Like that already. Like that only I will repeat. Okay? Okay, so first thing first, is there a game today? Not really. There's no Kahoot, there's no booklet, because I need to do some teaching today lah. Okay, but what I will do is I won't just write out. Okay, before I even introduce the thing just now, I want you to like find a piece of paper. If you are using a tablet, okay, your computer is a tablet, then open up like a PDF file, something for you to write on, and then save the work. Because I'm using these two slides here, got two slides here, to fill up information about series and parallel circuits. Okay, Lucas, I don't want to see your name, Alamak, wait, One participant share. How do I wait? Okay, done. Okay, okay. Can you if you have not done it, can you all find for me now either a piece of paper or some notes that you have for science around you? Maybe if you have, if your phone is a phone, sorry, if your laptop is a tablet, okay, then just open up a file for you to write notes on. Or you can also write it on this worksheet lah. Correct or not? Okay. You all cannot hear me, is it? You all can hear me, right? Why suddenly got request or caption one? Can hear? Okay. So what I will do, right, when I want to like talk about the series and parallel is, wait, where's my mouse my mouse I tell you keep disappearing from me one leh. Where is it? Okay, here. Is that I will use this thing called a simulation. Okay, so this thing, simulation, okay, is an electrical circuit simulation. Okay, you actually can go to like, you just type like electrical circuit simulation on Google. This is one of the first top one that will come up. Okay, from FET Colorado. PHET, not FAT, FET Colorado. Okay, so what they will have here is they let you design your own circuits, and then they let you see. I think I got introduced this last week also, right? Your class also, right? I think, correct or not? Then you can like adjust, create your own circuits, and then you will see the brightness of the bulb become like what? How much? Okay, I think I did introduce. I forgot. Okay, there's so many classes. I forgot already. Okay, so I will use this side by side like this. If I make it smaller like this, y'all can still see my screen? Can still see the words or not? Alamak. Okay, make it like this, like that. Can you still see what's on this slide? Is it readable? Yes? I need some response. I need to know. If you cannot see, if it's too small, the screen over here, then let me know so that I can adjust to make it bigger. If it's okay, give me a nod. Then I know it's okay and I can continue. Yes? Okay, okay, no response means okay, Okay, good. Thank you, Marco. And Kelvin, thank you. Okay, so get ready your pen, okay, or your tablet pen. Okay, and then let's write out the notes together first. The two concepts that I will introduce you today is called series and parallel. Okay, so let's write out the word series, circuit, arrangement. Okay, so this word here, series, and the other one, parallel, they are both referring to the different types of arrangements of electrical circuit. Okay, so when you say that the circuit is arranged in series, that means, right, all the components in a circuit, they all share the same electrical pathway. Okay, so let's write that down. Share the same electrical pathway. Okay, full stop. Okay, so this is describing what a series circuit is. Okay, first thing first, the word component here refers to the parts of a circuit. So from last week's lesson, you all remember what are the components of a circuit? You have things like a light bulb. You have things like your batteries or your dry cells. Okay, you have things like wires. You have things like switches. Okay, so when you're looking at how components are arranged, right, for us, for primary 5, primary 6, usually we only look at two first. We only place this and this as more important. Okay, so we will change the arrangement of the bulb. We will change the arrangement of the battery. Wires and switches we can ignore. Okay, so let's draw out. I hope you are copying this down also, okay? Okay, let's try and draw out how a series circuit looks like. First thing first, let's take our circuit to have like one set of batteries here. Okay, one battery, two batteries. So one set of batteries here connected to a single, two light bulbs. Okay, so since I want my circuit to be in series, the light bulbs must share the same electrical pathway. Okay, electrical pathway simply refers to the route that electricity travels in, aka the wires lah, correct or not? Okay, so light bulb A here and light bulb B, why my A so small? Okay, never mind. Okay, light bulb A and light bulb B here, they share the same pathway. That means they share the same wire. Okay, when electricity runs through the whole circuit, they will actually pass by the same wire through each of the light bulb here, A and B. Okay, so that's what it means. Hey, why I cancel my B? Okay. That's what it means to be in a series arrangement. Okay, so over here, we will say our light bulb is arranged in series. Full stop. Okay, let's move on to parallel. Okay, parallel, let's go to the next one. Where's my next one? Series, any questions on our series? Can series? Cannot, must say, okay. People, I tell you something, I lost my mouse today, not pet mouse, but like my computer mouse. So I'm struggling, a bit to control the cursor. Okay, so bear with me a bit. New slide, title only. Okay, let's go to our parallel circuit arrangement. Same thing also, we write the heading first. Parallel circuit arrangement. Okay, then after that, let's go and write out our definition. For a parallel circuit arrangement, we have the components. Components components each having their own pathways. Okay, no longer shared. Stop. Okay, so if I were to draw out how an example of a parallel circuit would be, again, I draw a set of batteries here, wires connecting to the batteries, and then two light bulbs A and B. But now each light bulb have their own pathway. So I will draw one light bulb A here. Okay, and then at this intersection point here, I will draw another wire downwards here, another light bulb down here. And I will label this light bulb. Okay, so you can see very clearly from here that light bulb A have their own pathway that electricity travels in. Light bulb B also have their own pathway that electricity travels in. They are no longer shared already. Can I? Okay? Okay. So, a parallel versus a series circuit, right? You can change the arrangement of not just the bulbs. Over here in my drawing, right? I actually give example of light bulb changing the arrangement lah. But it can also be battery changing arrangement. Okay, this one can change also accordingly. Can be series, can be parallel. Okay, then you might be wondering lah, like, so what if I have series circuit? So what if I have parallel circuit? Okay, the answer is it will affect the overall brightness of the bulb. Okay, so let's go on and create another page down here. Okay, another page down here to talk about the trends, the patterns that we will see if we change the series and parallel for bulb and battery. Okay, so I will divide the page into two. Like this. Okay, and then I will put here, this is for bulbs. This is for battery. Okay, before I go to here, to the next part here, you all understand what I mean by series and parallel, huh? Can, huh? Okay. No response means yes, can understand, huh? Okay. Okay, so for here, what I want to do is I want to show you, or rather we do together lah. Like what would be the trend when the light bulbs are arranged in series and when the light bulbs are arranged in parallel. Let's do light bulb first. Okay, let's do series first. Okay, so first thing first, when we are doing series, okay, I will use this thing to help you see. Okay, wait, I copy paste because I need two actually. Hang on. This one, paste. At the end of the lesson, I'll pass you the link, okay, if you all want to play. Hey, wait, that time also I passed you the link, right? Did I? Okay, never mind. I'll just pass you again the link before we end class today. If you want to play around with this, you can. It's actually quite fun, in my opinion. Okay, anyway, okay, let's have two setups here. One for series, one for parallel. Okay, so first thing first, I need batteries in a circuit, right? I put one battery here. And I like to have two so that later I can adjust a bit. Okay, one later, if I only have one battery, then I cannot make it into a parallel circuit, Okay, minimum two. So I put two batteries here, arranged. Okay, the batteries, take note of the battery arrangement. Over here, if you enlarge the thing a bit, okay, I'll enlarge for you. Over here, the one end of the battery here, you have a part that is like jutting out a bit, correct or not? It's not totally flat, there's a little bump over there. That part of the battery is called the positive terminal. The word terminal, like bus terminal like that, okay, Terminal. If you cannot remember the word terminal, right? Then you just say the positive end, END, positive end. Okay, so this is the positive end of the battery. This is the negative end of the battery. Okay, so when you arrange two or more batteries together, make sure you arrange the ends, the unlike ends together. So positive connected to negative. If there's another one in front, it will be positive connected to negative also. The way you arrange the batteries matter. Okay, I don't know whether you all still